Hi there, my name is Alex Live, and you're watching the next episode in the GraalVM streaming week. I'm very pleased to say that today we have a very exciting guest, and the topic of today's stream is very close to my heart, and it is something that I don't deal with daily, and I don't have a lot of experience, but the more the merrier, so I will learn together with you. Please welcome. I'm very happy to invite the guest here in our virtual studio, and that is Johan Vos. Johan is a Java developer, a Java champion, and a co-founder of Gluon HQ, and has a ton of experience in all kinds of things related to Java development, Java applications, desktop applications, and Johan, I'm very happy to see you here. Hi.
Hi, thanks for having me.
Right, can you maybe, my introduction was, I wanted to do well, but I'm sure I missed a couple of important things. Can you maybe introduce yourself a little bit more for our viewers, and maybe tell a couple of things, like what is your day job now and what you're dealing with, and a little bit of an intro.
Yeah, good question actually. What is my day job? I'm the co-founder of Gluon. So we're a small software company with, and our mission is to bring Java back as a first-class citizen to the client, as a first-class citizen, so not just Java, and connect those clients with enterprise software, cloud services, microservices, and so on. And that requires a number of things. So that means that we're working on and I spent lots of my daytime working on JavaFX, OpenJavaFX, and then also, of course, onto the bridge with the cloud. So my background in Java actually started in 1995 when there was no Java on Linux, and at that time Sun Microsystem was not interested in Java on Linux. So I started with porting Java to Linux together with as part of the Blackdown team, and the porting of Java, actually making Java available on platforms where previously no one believed in is seems to be some common thing in what I'm doing. So yeah, my main daily work is making sure that Java on any client runs very well, and I'm also working with Java in scientific environments. Quantum computing is one of the things that I'm working on as well. So using Java in quantum computing. I think that's
super interesting. That is super interesting, and that is a little bit orthogonal to the current topic of today's stream, which is of course the JavaFX, and creating Java desktop applications for various things that could be called desktop, right? For Java applications that have a user interface. But quantum computing is something that is very new. I feel like a lot of people have been talking about this for years now, right? Because we've heard about progress in quantum computing, but I don't know. Back in I feel like I was in high school when I first when people were very excited about that, and I feel like people are continuously excited about that. So that is very interesting that Java can be connected to those areas of interest, right? But we're gonna talk about JavaFX today, right? And you said that you have a ton of experience there, which is very good, because I don't have that much. I've looked at JavaFX, and I know some basic things, as like, for example, before JavaFX was a part of the JDK, right? It was built into the platform, and then started with Java 11. It got, I think 11, correct me if I'm wrong, but it got separated into a standalone library which I think makes a lot of sense. Can you maybe comment on that? And what is the current state of JavaFX? How people should consume JavaFX, and like, what's the setup there?
Yeah, yeah. Well, there's I typically have to talk a lot about the history of JavaFX because people are often confused for very good reasons. JavaFX started in 2006 at Sun Microsystems. Actually, it started a bit before at CBeyond when Chris Oliver was working there, and he created something called form follows functions, and that was a scripting language that then became JavaFX. It was then turned into full Java API, so not a scripting language anymore. And that contained that was actually the successor to AWT and Swing. So when Java started, the vision was that it was mainly a programming language for embedded devices, edge devices, and there was a UI needed as well. That UI was also used to create applets and so on. But the UI component of Java was actually rushed. They had to get it in time, and many people wanted to to improve it. And finally, around 2006, Sun decided let's reboot the client part of Java, and that was then called JavaFX. And then Oracle acquired Sun, and Oracle had some other priorities. Not really user interface for clients. That's fine. But then for some reason, JavaFX ended up to be part of the Java SDK, at least the Oracle distribution. And it was then part of that SDK, but it was not part of, for example, the OpenJDK SDK or other distributors of the Java SE distributions did not include JavaFX. Some did and others did not. So that was actually pretty confusing. So as a developer, if you wanted to use JavaFX, or if you wanted to create applications for JavaFX, you never knew if your end users had JavaFX installed, if they had the Java installed. So that was confusing. So therefore, I think it's much better that JavaFX is clearly separated now from the Java runtime. And especially now with the modularization, it made perfect sense to do that. So JavaFX is still available as an SDK along the Java SDK, but it's also available as Maven artifacts. So the different Java modules are available in Maven Central, and developers who are used to Maven or Gradle or whatever, they use the JavaFX artifacts in exactly the same way as they would use, for example, Spring. Spring is not bundled with the core JDK, yet there are many people using Spring. And exactly the same way as you can use Spring or any other API, you can use JavaFX. So by decoupling it from the JDK, it's much easier to evolve it. So we have more freedom now. We still follow the same release cycle as the JDK. Every 6 months there's a new release, and we are still part of the OpenJDK umbrella. So that gives us the benefit. We share the infrastructure, and we can work with the excellent team. Well, you know, your colleagues from the Java group. We share some of the patterns, and we benefit from the experience in that group. But we have our own release and distribution management, and so.
Right, and that is, I think this is a good development, and you are, of course, much more experienced. How do companies and projects that use JavaFX were like? What was the experience with them? Did they embrace that, or do you see more and more people kind of start joining JavaFX? Can you name maybe a few projects that have publicly, like, well, that you can name that use JavaFX, just to give us a taste of like what are people building?
Yeah, sure. So, well, actually, no. The one of the main problems with JavaFX is that so who is using JavaFX, and that is well, for example, financial, medical, healthcare, things where privacy, security is extremely important. So they don't brag about it. So it's if you do a website, you typically want as many people as possible to talk about it. But many of these JavaFX projects, school projects, are not visible. But maybe if I can probably share my screen and show show a few examples of real-world JavaFX applications. If I can share my screen, that is.
Yeah, that'd be great. Let me just check whether we're fine with that. Yes, you're sharing your screen. Let me just change the scenes so everyone is also seeing that, because who knows what they will be seeing.
They will tell us what they see. No. Let me. So I can show some screenshots.
Wait a second. Wait a second. I'm still trying to. How do I? Actually, I don't fully. I want this the other way around. Wait.
You want me to go to do this? No, I can do this in full screen, but that's not going to help you.
That's not. No. I have the full screen here, and let me just show you everyone else the full screen that I'm seeing, because I think this is mighty cool. And I will just figure out your camera here in the second window. Right, so I see your presentation slides. What can you do with JavaFX? And it looks pretty cool. That is some space stuff.
Yeah, all right. So this is something created by AI solution. It's used by the NASA, and they use it for calculating and visualizing orbits. I think this one is orbits between Earth and Moon for world space exploration that goes into deep space. And of course, they need to so they have very high requirements to software and to visualization. So they need to make sure that this is correct. You don't want spacecraft to drift off because there was a wrong conversion in the metrics or so. And so this is one of the areas where JavaFX is really where people use JavaFX because it is Java and because it is mature and because you can trust it and because it is secure and so. And of course, with this visualization, this of course helps a lot. And then medical software is also pretty popular. So this is from a German company that is using JavaFX. You probably saw similar applications like this. So based on whatever MRI or Röntgen or acoustic imaging that is applied, you can use the JavaFX capabilities. And why makes JavaFX sense here? Because JavaFX combines the power of computations that can be done on a backend or that can be done locally with a strong visualization. So it's all in the same language. It's not that you need to use one language, C++, for example, for doing computations, and then another more UI-oriented language for doing the visualization. No, this is really the same language. So that's where JavaFX is used and is very popular. And it also goes, and we increasingly see an interest in mobile and embedded, because people want to create an application once and then run it on desktop, but also mobile and embedded. And I think we'll come to that later. But if just scrolling around some slides, if you want to see is it popular? So this is very transparent, the number of downloads of the JavaFX SDKs that you can download from the Gluon website. They're also available on the on Maven Central, but and we have numbers of that as well. But here you can see how popularity of JavaFX is increasing. So this is an old, I actually should have created a new one because April is done now, but I created this mid-April or so. So the real number for April is higher. So disclaimer. So
Right.
yeah, it
And
is. It
this
is.
is, let me just, sorry, this for this graph, you said this is for downloads from your website. So I assume all the continuous integration environments and everything would go and download things from Maven Central, right? So this is mostly like people clicking buttons.
Yes. Yeah. Well. Yeah. Definitely. So this is. So this is. Well, it's not only. I have the Maven numbers as well here, and we selected that on unique IP addresses. April was not in there yet, so this shows again over 100,000 unique IP addresses or downloading artifacts. So CI systems only count once if they are, for example, behind the firewall, or if companies are with many people. So this is an underestimation. So, well, combined, I think that shows that JavaFX is in a great shape. And well, we see that if we, it's actually exhausting if we see how many users with requests, and so that we have. It's very popular. Also, there's a huge community around JavaFX, and that is one of the key reasons why I like JavaFX. There's this ecosystem of developers that are active, that create libraries, and that well, yeah, keep the platform vibrant and relevant. So that's it's pretty popular amongst developers.
Right. That is quite exciting, and this indeed shows. That is quite exciting, and indeed shows. I think this is a very healthy state of the project. I mean, like if you get 100,000 people on the website alone, I think not many projects can kind of boast those numbers, right? And even kind of, if you even think that the JavaFX is a platform for your application, so it's not a library that you put into every single one of your microservices and you download like in bulk from a continuous integration environment. I think this is very exciting. How so? Let's talk about this. Can you maybe guide me? So JavaFX SDK, right? What does it contain? What are the core sort of parts of what, like, of the JavaFX distribution? And
Yeah, good question. So let me see if I have somehow a slide that yeah, that contains what is in a JavaFX application. Typically, it's written on top of well, it's using some JavaFX libraries, but also other libraries. And those are using the JavaFX platform, or a JavaFX application uses the platform as well. And ultimately, that then runs on hardware. So if we zoom in on the platform, it contains 3 layers. On top of it, we have the JavaFX APIs, which contain the well, which are the Java APIs like we all know them. So this is really the Java layer, the platform independent layer that developers play with. And then at the bottom, we have the low-level rendering and the Windows system that talks to the real operating system and to whatever is available. So that, for example, enables the hardware acceleration on desktop, but also on mobile and embedded devices. And that is very platform specific. And then there's a middle layer that somehow binds the platform independent APIs with the low-level, high-performance graphical drivers. And that is actually something that makes JavaFX a modern graphical development environment. The combination of mature application on top and high-performance graphical pipelines at the bottom. So that is more or less how the JavaFX platform is structured.
right. So there is a Java API, there is native API, there is the code that glues them together. Actually, there is a question in chat from Belu, which might be appropriate to ask right now. Belo asks, Johan, do you know if TestFX is maintained and will there be new releases? And claims, and they say that it is very important for critical JavaFX applications to have good and maintained testing framework because and yeah, I think without tests, it's really hard to move projects forward. So
Yeah,
a couple of words
absolutely.
in general about TestFX, what it is, and because I don't know what it is.
Yeah, well, there are a number of testing frameworks for JavaFX, and TestFX is one of them. But even apart from TestFX or any other third-party framework, in JavaFX there are I don't know how much, but thousands of tests that are run on every commit. So the quality of those tests and the test coverage is very high. But with TestFX, and I've no reason to believe why it should not stay working. With TestFX, developers can use some part of the JavaFX API, the robot API, to simulate events, for example. So if someone would click on this button, then I want this action to be fired, and that is what can be done with TestFX or with other test frameworks. So that is indeed important. Now, everything that you do with regular Java test frameworks, like for example JUnit, can be done with JavaFX as well. And actually, whenever I make a commit into OpenJFX, I add a few JUnit tests. So we use JUnit as the first test suite for JavaFX, but TestFX adds a layer on top of that because it really focuses on the graphical aspects of JavaFX, and it makes sense indeed to stimulate that. Now, you need to be aware that JavaFX is a bit special in the landscape. It's not that there's one big company behind. So it's not like many frameworks are sort of managed, driven by, for example, Google. Yeah, of course, Google only does that to please developers and save the planet. Or they might have some other reasons to give developers things for free. The JavaFX is really a community-driven project. So if you like something and you're using something and you're benefiting from it, then I think it's good practice to give something back, and that can be feedback to the creator, that can be financial contribution, can be advertisement, and so. And TestFX is one of those many user community-driven projects, and I highly encourage people to support it. There's a huge ecosystem in JavaFX, many tools that that you can explore and that you can work on, improve, and benefit from, of course. So just quickly browsing over a few projects.
Right. Yeah, a couple of interesting screenshots there. I like that. I like visual things. I like pretty things, but they are mostly usually visual. So that warms my heart. Right. So it's a community project. Can you maybe tell a couple of words about how, like, so when I download JavaFX, it's a Java library, so it will come in the form of jar files. But there are also native libraries that you mentioned. Right? Are they packaged in the jar file? Do I get them somehow separately? What's the getting started with the JavaFX looks like? Just very briefly.
Yeah. So actually, there are two approaches. You can download the SDKs, or you can use Maven. And if you download the SDKs, the native libraries are packaged along the jar files. If you use Maven, then the native libraries are part of the jar files that you download for your specific platform. But in general, and maybe let's see if we can stretch our luck a bit. I can maybe show this with an IDE, NetBeans, because the starting point for most developers is actually their IDE. And what we do is we make sure that there are IDE plugins for NetBeans, IntelliJ, and Eclipse. And with those plugins, you can easily create the JavaFX project. So you don't have to worry about that lower level part of JavaFX. And actually, even if you don't want to use an IDE, or if you want to well, go a bit lower, like for example, command line, I think you can still create a Maven project from a Maven archetype. So one of the things, so in NetBeans here, I can create a new JavaFX project starting from a simple Maven archetype, and I give that GraalVM Twitch a name, for example. And well, you can change anything that you would otherwise change in a project, and then your project will be generated for you. So the POM file is generated, and the basic components of the platform are generated as well. Sorry, the basic components of the application. Might take some time because let me stop the unpacking of the repository here.
Right,
but so the result of this is now a project for NetBeans, and it contains source code, just the default application, and you can see the so this is your Hello World JavaFX application. You see it running, and sorry, you see the source here. You can change things, and if you want, you can run the program. So let's run this here locally.
Right. So the getting started developer experience, what I'm hearing and what I'm seeing is pretty straightforward. So my main experience in Java applications comes from web applications and microservices. So I'm very accustomed to all kinds of frameworks like Spring Framework or Micronaut, where you like the code pattern here is very familiar, right? So I have a class that extends something, but this is the main class and it contains the main method, and then just say launch my application, and then it goes and determines the component somehow, and then creates the UI, and I can see that it says hello JavaFX 13 running on Java 12. That's an odd choice of the JDK to run an application. What versions of Java would you recommend for people developing JavaFX applications?
Yeah, it's actually funny, and I don't know how. Well, I have quite a few JDK installs on this machine, so I don't know how it ended up with the 12 here. But for example, the 13. Let's have a look at the POM file. Oh, but by the way, before I do that, when you talk about Spring Boot and so, indeed, JavaFX is pretty similar. And if you want to make it even easier to get started with a project, we have started gluon.io, where you can also specify a name, go by the artifact ID, and then some additional features. And you can then create a project that you can then open in your IDE and see the POM is generated. So this is also very similar to what Micronaut, for example, is doing to get started. So I think this is extremely important because we want Java developers to be able to work with JavaFX without any hurdle. So what we want to avoid is that a Java developer, when he needs to create a UI, that he needs to learn JavaScript or HTML or any other language. And Java developers or JVM developers in general are skilled in whatever they learned, and if they are used to work with Micronaut or whatever, then if they can use the same patterns to create applications that client applications, that really saves lots of time, and it also makes it much more maintainable. So if we look in the POM file, you see that we have configured here version 13 of JavaFX, but it can be anything between 11 and 16. What do we recommend? I actually for the JavaFX version, we do recommend either the latest, which is currently 16 or 17 early access, or the latest long-term support, which is 11. And for Java, we make sure that everything works on Java 11 and beyond. So the JavaFX components themselves, they leverage Java 11, and they don't use syntax or APIs that are not part of Java 11. So if your application, of course, uses something from Java 12, it requires 12, of course. But 11 is the baseline for all JavaFX development. But we make sure that JavaFX runs first class on the latest Java. So we test everything currently on Java 16, and we make sure that everything works on 16. But we also make sure that everything works on 11, and that's it's written in the build and in the CI systems of JavaFX.
Right. That makes a lot of sense. I know of a lot of frameworks and libraries that keep the baseline Java version a little bit older than the current, which is 16. To be honest, I don't know any, like, honestly, I don't know any library that just has the baseline on 16 only. So 11 makes a lot of sense. Can you recommend any JDK distribution, or you think they're more or less similar?
So I don't think there's a specific JavaFX requirement that would make one distribution more suitable than another. So I don't think that JavaFX here is or leads to a distinguishing factor. Well, we test everything with the OpenJDK builds for the regular dynamic versions. But we will come to that. We also have static builds, and those are nightly tested against the GraalVM builds. So, but we know that there are many people using Adapto, OpenJDK, or Zulu, or Bellsoft, or Corretto. So it works. It works on all certified or valid 11 SDKs.
With the whole ecosystem, right? Yep. How does it work? Like, do you recommend? Do you package? I know JavaFX is fully modularized, right? I've heard that somewhere, and please confirm if that's true. But also, how does it work? Do you do projects that, then by you I mean, like, what's the common thing in the ecosystem that you know of, right? Do people package them with the self-contained JLink runtimes, or do people require like a JDK installation on the client machines, or what's the common way to do this?
So there are a number of options, and in the past, not only the common but the only way was that you required the end user to have JDK installed. And then that user had also to maintain that JDK, so update it very often and make sure that he had the latest secure version. That was the only way. And that works well for developers, but that doesn't work for end users. So we are moving away from that approach. And one possible approach is indeed that you use a JLink or JPackage to package your JavaFX application into a native executable, or a DMG file, for example, for Mac, or an RPM on Linux. And that is something that JPackage can do for you. JPackage is sort of the successor to the JavaFX packager. So it's broader than just JavaFX. It can package any Java application, and it also enables you to bundle only the Java modules that you need, so that you don't have too big of a runtime. And that's very well possible, and yeah, that is pretty popular amongst JavaFX deployments. But the other approach goes one step further, because if you use JPackage, you will still run a JVM at runtime, and with all advantages, because you can use the JIT, but also with the disadvantages, the slower startup and the larger memory footprint. And to overcome that, we use we have plugins that allow to use GraalVM native image for compiling everything ahead of time, and then we add some functionality to the object file created by native image to bundle it with everything that is required, and literally everything, so that we end up with a static image. And then the end developer just needs to install that static image, and that of course makes it much easier for end developers. He doesn't have to download or install or maintain anything else apart from that image.
Right. The end users would certainly be more accustomed to just download the binary, or like download the archive with the binary. That is for sure. And it also, I think that has to do something with how JavaFX can be run on iOS, and because I don't think you can have like a working JIT on iOS, right? Because of the limitations.
Yeah. Well, technically you can, but Apple doesn't allow apps that dynamically create code. So the JIT is a no-go on iOS. So and that is actually a nice detour that circled back to desktop and actually to server as well. And it created a great opportunity, I think, for many developers. So if you want to run applications on iOS, you need to make sure that they are compiled for iOS. But Java bytecode requires a Java virtual machine, and that is something that is not allowed to run on iOS. So what we need to do is to compile the Java bytecode ahead of time into native iOS code. And that is something that GraalVM native image is doing, for example. What it compiles, so GraalVM native image will compile the Java bytecode to some native code. And that can be, well, typically that is code for your own system, which can be Linux Intel system or an ARC64 system. But GraalVM can also cross-compile to other targets. And for example, it can cross-compile from Linux Intel to ARC64. And there was also an LLVM backend in GraalVM native image that allowed you to transpile your Java bytecode into LLVM IR bitcode, and then you can use any of the LLVM front-end compilers to target, for example, backend compilers to target iOS, for example. So by combining all those things, we managed to compile Java classes, the Java bytecode, into native iOS code. And then, of course, it needs to be bundled with all the native code that's required, and the native code for the Java class libraries, the native code for the JavaFX libraries. Remember the platform-dependent hardware acceleration, and so. And that is actually what Glue on Substrate is doing, and that's what I have here on this slide. So your application code and all the dependencies is retrieved by Glue on Substrate, and it will Substrate will then pull in the required SDK for Java, which contains then the static libraries, and the SDK for JavaFX, which contains the static libraries for JavaFX as well. And it will use the GraalVM native image AOT compiler to generate an object file, and then it will bundle everything, and it can also add the Glue on Mobile, but that's a commercial add-on to make your applications even more shiny. And the result is whatever you want to combine can be combined into a native image that then runs on desktop, but it also runs on mobile or embedded. And actually, so the first step was that it should run on iOS because it was a requirement there. But it turned out that, hey, if we are doing this step for iOS, why don't we do it for Android, but also desktop as well? And that is what is now more or less getting the standard, so that you can build your JavaFX applications and distribute them as standalone native images.
All right, so like that is inspired by the necessity on iOS. I didn't know that. That is a cool bit of information. Right. Yes, but like this is very interesting, right? So there are many moving parts, and there are. When you say that GraalVM native image allows you to use the LVM backend and cross-compile things, what I'm pretty sure happens is that you have to have like a high level of expertise to make it work. So, right, I know that there is a LLVM backend, but I don't think it allows you with a very simple switch, for example, do so. So this is where I assume the Gluon plugins and configuration and environment around those technologies come in. That simplifies that. Can you do you have an example? I have an iPhone here, but I don't have any JavaFX apps on that. Do you have an example of an app that you can show?
Yeah, actually, I'll send you a few links, but so you can probably see my phone here.
Wait. Yeah, we're gonna do this properly. Right, this. Yeah, we can see your phone.
Okay, so we're live, so I can't cut and try again probably. Oh, so this is what they used to call the demo gods at Java 1. So and I have to click without seeing what I'm clicking. But so there are 3 applications here, and none of them is created by Gluon. So that actually means that other people managed to create applications. So this is sorry. That actually means that it is possible to for developers to create applications. So this is some sort of a resistance calculator that that calculates. Let me see what I have to do. That calculates the total resistance of a resistor. So that's yeah, that just shows some parts of the
that's
basic
an amazing app. That's an amazing. I had a friend in the university who created that app, like a similar application for Android. That's amazing. I'm gonna check later if that is the same person. Shout out to Victor if that is Victor. But
so this works on Android as well. But and that's also something important to mention. So this same Java code works on Android as well, but then running the GraalVM and not the Android Dalvik Java kind of thingish. So now maybe to show that that this is a that the performance is pretty okay. I just removed the app from memory, so nothing in the sleeves, and when I click it again, you see how fast it starts. So this is really a cold start. So and that is thanks to the fast startup time of a GraalVM native image. What do we have here? So this is someone who created an eBay watcher. So I don't have an account there, but you can you can watch and things on eBay and be notified when the price drops below something or so. So this is more sort of a business application. So and then finally, so this is mini golf. So this is an application I think created by Paul and Gil Anderson or their son. And this is more a game. And let me see how does it go? Yeah, it's pretty addictive, but it's hard to play in reverse, I think. So bear with me.
It's a game. Yeah, I can
It's a
see
game.
that.
Yeah.
How do you think? Like, what's the FPS count? Does it go to like a decent, like 60 FPS?
Yeah. So have a look at.
Yeah, it's pretty smooth.
Yeah. Oh, did I make that in one? Oh,
Yeah.
that's my best one so far. But the second is extremely hard. So that's but yeah, we have I think some things are kept at 30, but typically we go for 60 FPS. So that is well, we use the same underlying hardware as all the other iOS applications. So that that's close.
So close. So close.
Yeah.
Right. And that is excellent, right? And it uses so you said native libraries that they get access to the normal like rendering pipelines of the device and operating system. So yeah, I think that should be reasonably like that shouldn't be a bottleneck then, right? Because that's the same as other technologies are using. That is mighty cool. That is absolutely spectacular. Right? Let me just change the scene back to our normal ones. Oh, that was very cool. I need to download a couple of applications like that.
Yeah, so people often ask, are you using the iOS native libraries? Well, we're not using the iOS UI components like button or so. All of these are JavaFX buttons, but they are rendered using on iOS OpenGL ES. And the iOS controls themselves are also rendered via OpenGL ES. So we use the same underlying rendering pipeline, which allows us to be extremely fast. So this is not something in HTML that is then interpreted. So this is really going to the bare metal. And actually, those phones, but also those embedded devices, and so most of them are sort of Linux systems on ARM chips. And it's if you go to the core of Linux and the graphical drivers of Linux, you get the best performance.
Right. That's interesting, right? And then, so this is the native image, right? But native image, if you use native image specifically, that outputs you and gives you the binary file, right? So it's a binary file that then it will include your Java code that is compiled ahead of time to machine code. It includes your dependencies, and as you showed, it will include the native code from the OpenJDK, right? So if I call some native methods, like I don't know, like the math methods that are, well, I don't know, not sure math methods, some methods that are like public native method in a certain class. So those are included if they're reached, and then native methods from JavaFX. But like the result is a binary file, and I assume that you need to package that for your specific platform. So if it's a like a Windows application, you need to have a like an installer or like a zip archive. If it's like a Mac thing, then you package it with the Mac like environment around the app. Does JavaFX do that or help doing that, or is that a prerogative of a developer?
So that is something that the ultimate packaging is something that we're working on, because in this sense, I think JPackage can be helpful because it wraps things in a DMG, for example. What we have as a result of Glue on Substrate is an executable, but that can be packaged into using any Windows or Mac packager or so, or an RPM. We already provide additional tools for iOS and Android, because on iOS it needs to be packaged in an IPA, and on Android it needs to be an APK. And we have actually community did that integrations with GitHub Actions, so that so the GitHub Actions invoke Glue on Substrate to create an image, and then there are some other actions that already do this last step, so convert it into something that can be uploaded to the Play Store or to the App Store. And I'm pretty sure there are GitHub actions that already do that last step to convert things in native packages for Windows or Mac or Linux or so. But it is something that, so this is pretty new, and we are looking together with people from the community how to provide the best developer experience here. And again, we try to do everything. We try to allow developers to do everything from their IDE. So if let me maybe quickly open a project that's targeted towards that is targeting this. I have quite a lot of samples. Oh, let's just take the simple HelloFX project. If you look at the left side, you see the so this is the HelloFX project, which is just hello. I can actually run it if you want to see code in action on desktop.
Yeah, let's run it.
But it has some additional targets like client package, and that will package the application for the for the platform that you're currently using. Yeah, sure. So let's run this. If I can find my terminal. Do you want me to increase the font size for the terminal? That
yeah, maybe a little.
That might help, I guess. How do you do that on Apple? I typically I don't use the Apple for development.
Command plus.
Command
just
plus.
like this.
Oh. Okay. Yep. That.
Yeah, I think this is decent.
So I typically I mean, I use NetBeans for doing the development, but I most of my deployment, and so I do that command line. So we have an HelloFX here with which is actually the same HelloFX as the one that I have in NetBeans, which is probably just doing what we used to do before, but then we were running it in Hotspot, and with this one we can run it in we can compile it ahead of time and run it with a native image. But you know what? Let's take a sample that's slightly more complex, but not really. So we'll first run this code with whatever dynamic Java that I have here. So this is probably going to be Hotspot. And when we run it, we see this is the application. So this is a very basic JavaFX application, and it's running inside the Java virtual machine. I can also, and I'm, you know what? I'll run it first because I think I built it already. If I now use the Maven command client run, so the plugin is going to use the Substrate APIs to make sure that everything is built using or I should point it to call VM home. Sorry.
No worries. Right. So there is the client plugin by, I think this is the Gluon client plugin that simplifies the lifecycle of application working with the native image. So when you do the client run, it should find the pre-compiled artifact if that exists, right? And then run it. So this is now the binary native process that doesn't depend on the JVM. That is
exactly. So and actually to prove that, we can also we can run that client if I know where it is located. It's called Hello Gluon. So if I ask, so this is a 64-bit executable. So this is the result of what Gluon Substrate is doing, and I can run it manually. And you see, here it is. And
That is
of
very
course,
cool.
I can also, for example, let's say that we want to give it only 30 megabytes. So we set the maximum heap to 30 megabytes. See, it runs fine. We set the heap to maximum 13 megabytes. It still runs, so it's
How low does it go?
well, it
Can
doesn't
we?
work with 1 megabyte. See,
Yeah, but
then
I mean, yeah. Let's not like show a decent number, like 8. I don't know.
yeah, well, I think yeah, this is close to the limit. So I think 12, for example, should work. Yeah, but
Right.
8 is not
Okay.
working. So it's somewhere in the middle. But the main thing is it depends on the amount of images and the amount of media that you're using. And typically in modern applications, the code size is smaller than the image, well, than the size of the images. Let me show another example. And
Can you, sorry, before we go to another example, and yeah, the data I know is gigantic. Like if you play it in games, I'm not sure if like whether you're a gamer or not, any updates like probably consists of like hundreds of gigabytes, and that is mostly the assets, right? Not the code difference. Can you run just how big is this Hello World application if you run LS on it?
so the footprint of that application itself is
70 megabytes. Yeah, approximately like a small small microservice. Nice. And
yeah.
then probably you can compress it further if you wish.
Oh yeah, we didn't do any optimization on this yet. So now this is a more complex application, and this is 132 megabyte. But you really need to see this. So we run it. We can run it the same way with. Well, we're now. This is so not running on hotspot. So this is running directly on native image, and so the goal is to not get killed by the stones here, and
right. It's a little bit choppy on my end. I don't know if this is the screen sharing or if this is the game performance.
Yeah,
it's
no. It's I have 60 frames per second here, so
yeah, I have probably the Zoom screen sharing version, which is a little bit choppy.
Yeah, I see.
But this is the SpaceFX application that is it's an open source JavaFX application, right? By Garrett, right?
Yeah.
So if you go to github.com/hansolo, you will definitely find the SpaceFX, and you can try building it yourself, or maybe just download pre-built binaries. Yeah, exactly. So I recognize that app, and you can test that. So can you say so those applications are currently built with GraalVM native image. Would those work with the recent release 21.1, or does it require like a special version of GraalVM? How is that integration handled between the
so I think, well, you saw that I had to specify the GraalVM home here, and it's pointing to 21.002. There's one thing with the latest JavaFX. There's one fix that we we try to contribute back. So we created a pull request. It's not integrated yet, so for that we have a dedicated build of GraalVM native image, but we try to stay on par as well. So it definitely works with, or at least all the releases that we do should work with the latest releases of GraalVM native image as well.
Right. So it's I assume if you do a release for every JDK version, right, that is one every 6 months, and then you probably do like more releases. And since you said that you test against native image nightlies.
Yeah.
Then that means that it's supposed to be working with the head versions.
Yeah, pending that one fix. So we have our CI is nightly merging the whatever happened in GraalVM with our fork that contains that one fix, and then all our tests are executed on that nightly, and whenever something goes wrong, we jump and we look what's happening. So we don't want to build up technical debt.
Right, right. That makes a lot of sense, especially since you mentioned that it's the resources, development resources, are always a precious resource, as with any project. Let's talk a little bit about performance. So you mentioned that the rendering pipeline and everything is handled by the native libraries. So I assume those are for the rendering, that would be the bottleneck. Do you experience that the Java code often is the bottleneck, or do you think like from the performance point of view, right? If you would compare those deployment methods, right, as with the JVM or as the GroundVM native image, uh, do you developers need to have some things in mind there, or do you think they're roughly equivalent and people just need to test what is their like performance requirements?
Yeah, so it's you can create very performant applications with JavaFX, but it's also very easy to screw performance as it is with any technology. So I think with JavaFX, it's especially important to understand where your bottleneck is, and it can be in the CPU or it can be in the GPU. So when it's in Java code, it's most likely going to stress your CPU, and if it's in native code, the low-level native rendering, then it's going to stress the GPU. Now, there are a bunch of JavaFX flags that you can use that will give debug information. And those are very helpful if you want to trace performance, especially for finding the balance between CPU and GPU. And it's really different. Most performance issues in applications that I've seen are mainly due to business logic that's not parallelized, or that's or that contains memory leaks. And so the typical Java performance issues, you see those in JavaFX as well. There are a few patterns. You should not do computations on the rendering thread, for example. Typically, on modern devices, the user interface is not the bottleneck. Well, it depends, of course. For example, and I just looked at that. It's something that we did a very long time ago, but this is using a Tribuo, which is a project from the Oracle Labs as well, and this shows this visualizes some classifier work. So it does lots of computations in the background, and then it visualizes them. So this is a combination of, and AI in general is a combination of computations and visualization. And it can be done very well. It's also very possible to make this extremely bad performing, because the computations may clog up the CPU, which is also needed to do some rendering. So you need to, you need to be aware of how the system is working. At least it helps you, especially if you run into performance problems. But again, because this is Java developers know what to do in case they run into performance issues.
Yeah, so I assume all the normal tools like the profilers, the like Visual VM can connect to this, and then you can monitor and navigate your the performance of your application. That is cool. That is very interesting. And Tribio, if you didn't know, when you were watching us, it's a machine learning library, and I've seen recently there was an announcement of that. It's an open source library, and it offers some kind of cool features for specifically machine learning targets the normal formats. So it works with the, I don't know, TensorFlow backend and stuff like that. But it offers some developer, like enhancing the developer experience for using those libraries. So if you're doing machine learning and you're doing that in Java, Tribio is something definitely that you would like to look at.
Yeah,
I'll put the link to that somewhere.
And one of the additions that I think, because this is actually a mobile app that I'm showing now on desktop, but in many cases with AI, the data is sensitive and should stay private. But if you do part of the calculations, especially the predictions, and so if you can do those on the client, on the mobile client, you don't have to send your data to the cloud where it might be intercepted or so. So therefore, if you can do the combination of computations and visualization on the same device, on the client device, that's a big it's a big win for for the privacy of the users.
Absolutely. Processing the data where the data is I feel like a more and more important topic nowadays, which is very cool. You mentioned performance, and you mentioned that you need to be aware of certain things, how the application and the library and the whole stack actually behaves to write applications that feel fast and respond fast to user actions. Do you think there's another large class of applications that maybe deservedly get a lot of negative feedback for their resource hungriness and everything? And of course, I'm talking about Electron apps, right? I'm not sure how well versed you are in the Electron app development, but if you compare those two, do you think it's easier to create sluggish applications using JavaFX, or if it's easier to create sluggish applications with Electron?
Yeah, well, I think the main difference is if you're a Java developer, I would recommend using Java with JavaFX, and you can still create sluggish apps there, but you can also create very slim apps with fast responding without 200 megabytes footprint. If you're a JavaScript developer and you want to use Electron, that's fine, I guess. But you need to be aware that the JavaScript is not Java, and that you cannot. I know the JavaScript runs on GraalVM as well, but you lose some of the advantages of Java, and that's not only the stability and the maturity, scalability, security, and so, but it's also the large ecosystem and the fact that you can use something and be confident that it will still be there in a year from now, which is with AngularJS, for example, not the case. But I think the main thing that we try to address here is that as a Java developer, you don't have a reason anymore to go to JavaScript or HTML. And if you look at many forums, you see that people are making fun of JavaScript. And then I sometimes wonder, why are they doing JavaScript? So why are Java developers doing JavaScript? And well, if there's no alternative, then yeah, of course you have to do JavaScript. But if you can do Java and run on the desktop or on embedded or mobile clients, then I definitely say go with Java and avoid the problems that you will run into if you go to the dark side.
All right. Yeah, and this is let me put you back into the focus here. Right, and this is in general one of the also overarching themes of what GraalVM offers, I feel, right? So if native image allows you to do cool things, and then you don't have to turn to other programming languages for achieving, for example, performance that you would like, performance profile that you would like for microservices or for native apps on mobile devices, or like in general, like sort of smaller constrained environments. And it is very cool to see that JavaFX also works with that technology. And it's very cool to see that Gluon and the moving force behind the JavaFX nowadays are embracing that. That makes me very happy as a part of the GraalVM team. That makes me very happy. Right. Can we maybe talk about a little bit about the next steps or the future, or maybe a little bit more like a larger ecosystem of the things. So I know that there are multiple different backends for native rendering pipelines, and they are also platform specific. And I'm sure that JavaFX by default gives you a reasonable choice, right, and like allows you to do reasonable things. But what backends are supported, and uh, what would be your recommendation in like 1-2 lines to like a novice like me?
Yeah, typically for desktop, JavaFX has the most performant backend that you want, which is currently so directly on Windows, and OpenGL on the other platforms, and with a Metal port for macOS in the pipeline. So you're covered there. On mobile, we also use OpenGL ES, and we might use Metal in the future on iOS, maybe Vulkan on Android. So there's some research work being done. On embedded, we are now also using a DRM, which allows direct access to the frame buffer. So we are directly on top of the Linux kernel, and that is extremely performant. So on this Raspberry Pi devices, we easily get. So that's my latest toy on my desk that we easily get 60 frames per second with SpaceFX as well if we go full screen native, and that is because we're again on top of the iron actually. So those backends are definitely yeah, something that, in my opinion, is the most important part of my work in OpenJFX. The community is large, and the community works on additional libraries like editors, applications, for example, calendar software. And so that's something that we won't do in JavaFX, but in JavaFX itself, we will make sure that library developers can create everything. So we have to make sure that everything works extremely performant. So the pipelines need to be first class, and we need to maintain them as operating systems and drivers evolve. So that's indeed one of the things we keep an eye on for the future. But we also work on, and I'm actually personally very interested in the polyglot aspect. So far we talked about Java, and JavaFX with Java, but there are some people working with JavaFX and Kotlin or Scala, and I'm actually pretty excited that so one of the benefits of GraalVM is that you can use all those languages to create a single application that still benefits from different languages. And the AI sample that I just showed can be one of those examples, because you might do some logic, some processing in Python, for example, and then do the heavy weight processing native, and render everything with JavaFX. So that polyglot aspect is something that I think will be very interesting to domain-specific development that needs a fast, highly responsive user interface in a mature, proven language.
That's a very good point. I don't even know how like Python developers create UI for their applications. I'm sure that is because I'm a lousy Python developer, and the people in the community, in the Python community, who actually deal with that have their means and have their tools for that. But merging those two technologies is indeed could be very interesting, because Python gives you access to certain ecosystem that is known for example, its applicability in machine learning, and merging that with the power of creating UIs for multiple applications, that could be very, very cool. And specifically, maybe you don't want to do machine learning on the actual device, because if there is no jitting allowed on iOS, for example, then probably the Python interpreter will run rather slowly. But then again, it will run. So if you just need to process some data and use a library to kind of manipulate some data transfer objects, if you excuse me for using that term, and passing that data to the UI, I think that is a very interesting approach. I don't know actually if that would work out of the box currently, but I assume that this is sort of a little bit of a research area that could be interesting.
Yeah, it is a research area, but we also, I think I once talked about it at Oracle Code, where, well, this Triburo sample, for example, it was with deep learning for JDen from a conduit, where you have something like that, so you can locally do some processing because the data, you want to keep the data private, but on the other hand, based on what the user, based on the user feedback, you might want to improve the model. For example, if you're in a car and the car suggests that you slightly move to the right because it sees a pedestrian or so, and you don't do that because it's not a pedestrian but a bike or so, you don't want to send all the images to the backend, but you do want to send the correction that you apply to the model, so sort of the gradient, back to the server. So, and that is, and actually, so that is the whole business point of what Gluon believes in, connecting the client with the server in an intelligent way, only sending what is needed without the user having to set up an HTTP connection and so, but making sure that you can do as much processing as possible locally, but also that you connect to those cloud services where the model training and so is happening. You can do training on a client as well, but for large data sets, and so it's beneficial to do the retraining in the backend, and combining this and using the best technologies on the best basis is key, I think.
Right. And another in the polyglot space. Besides those use cases of incorporating different languages, which are certainly very interesting, there was a recent announcement, I think from January, from the GraalVM team of a project, Java on Truffle, which is the Java implementation on top of the Truffle framework in the GraalVM project, which is sort of raises Java to the level of other GraalVM Truffle languages, right? So it doesn't only run on the host level, but it also runs through the interpreter that can be treated with the Truffle framework at runtime. So one canonical example of the cool things that could give you is the JShell demo, where the base application is running on the JVM and is compiled as native image, and then that embeds the JVM inside that Java application. All right, and that can run the JShell commands. Do you think that would be interesting for JavaFX applications somehow, or what do you think in general?
Yeah, so we'll have to investigate it a bit more. But what this might help for is one of the problems, and we know that of ahead of time compilation is that it takes lots of time. Well, it's you compile everything ahead of time, so you gain at runtime, but that means that you need to spend some time at the build time. And if you're deploying on an iOS device, for example, and you see that this is not perfect, I want this to be a few pixels higher, or I want this to be more to the right. If you then need to go through a whole new cycle, 5 minutes compilation, for example, with the deployment, so that's it can be frustrating. Now, we do recommend developing using your desktop environment and only ship it to the device once you're really ready, but still development needs to continue when you're at the device. And in that case, some sort of an interpreter on the device might help. Using the exact same technology as what you would use in production, because then Java on Java might allow you to you run the code on the device or on an emulator, and you don't ship that. That's not going to be accepted into the App Store, for example. But during development, you can just send your Java code, and it will be slower, but it will be functionally the same as if you're using the real image. So that might help during development for doing live preview. So and also having more the WYSIWYG feeling that you can you change your code and you immediately see the result. You won't get 60 frames per second, but you can you have the WYSIWYG feeling. So that combined with the with everything we have now is, in my opinion, might improve the user experience even more.
Yeah, that's a cool, interesting idea. I think I didn't expect that answer. I don't actually know what I expected, but that sounds like a thing worth investigating, because you can ship the interpreter without even the JIT compiler, right? It won't need to run any, or it won't need to create the executable memory, right? So technically, it should be even maybe within the constraints for the App Store. But you definitely can. There needs to be. I assume there needs to be some glue code that will kind of bundle and kind of connect this dynamic interpreter world with the host application that is compiled as a native image or runs in the emulator. But then definitely you can remove that glue code and kind of like link to the API directly with some sort of build step configuration.
Exactly, and that is actually what Glue on Substrate is doing. And people sometimes ask, what is it doing on top of a GraalVM native image? Well, I think that glue code and making it easier for developers, because we know that both JavaFX and GraalVM native image might have things that are hard to configure, or that are easy to forget, or that are that require some boilerplate configuration or so. And this interpreter and the glue between the different components, that is exactly what we built in Glue on Substrate, so that it becomes easier for developers. Well, we are all the founders of Glue on are developers. We know what frustrates us, and we want to take that away from the developers. And I think that's maybe one of the reasons why I think we're succeeding in getting more interest in JavaFX from developers, because we really want this to focus on developer productivity and tap into the developer ecosystem.
Yeah. Replacing frustration with happiness is
exactly
the certain recipe for being a popular project and successful project, right? I don't think I have any more questions myself. There are a couple of questions in the chat. If you are watching now and you have more questions to either me or more probably to Johan, now is the time to ask. I see a question from Bruce. Bruce is asking, are Gluon's tools and libraries free for commercial projects? Can you maybe comment on the licensing terms and the conditions there?
Yeah, so we have two goals. First of all, for developers and open source projects, they should be able to use everything for free. That's because in our heart, we are developers, so we want everything for free. If you want to, some of the things are for free also for commercial support, for example, the whole JavaFX, and you can also use Glue on Substrate for free. If you want to use the additional UI components in a commercial project, or if you want to use the hardware acceleration using DRM on embedded devices in commercial projects, then we have commercial licenses for that. And if you want to connect your application with cloud service and you want to use Glue on Cloud Link for that, that's usage-based fees that we have there. But the point is that, well, we want to be profitable, of course, because otherwise we can't do this. So we want to make money somewhere, but we want developers to be able to do everything for free. And we want companies to get assured that they get commercial support and that whatever they work on is really production grade and yeah, commercially supported. And we have licenses for that.
Right, good answer. And I think it's very important for the projects to have like a monetization strategy, right? Very many open source projects depend on just the pure willpower of a few overworked developers, and that's how they stop being excellent projects. So yeah, if you, as Johan said, like check out the licenses, check out the offerings. If you are a developer, allegedly this is, you can use things, and JavaFX is a library, right? So you can use that for free. And if you want commercial support and offering, and I assume like some security and backward features for a certain version, then Gluon provides the commercial offerings for that. Bello in the chat here says, "Thanks, Johan, for your great work!" Exclamation point. And I sincerely join that sentiment. Thank you for your work on JavaFX. I think that's a very important part of the Java ecosystem. I learned a few things today. I saw a couple of samples that I didn't see before. What would be like if you would recommend someone, if someone doesn't often come and kind of deals with JavaFX applications, what would be the learning path? What tutorials, books can you recommend?
Yeah, so I would first recommend go to openjfx.io, which is the start site for JavaFX, and it contains links to a limited number of tutorials, but ones that we really like and ones that are really good. There are a few books. Let me see. Oh yeah, so written by, well, a number of people actually. So yeah, this is a shameless plug. I think I got even half a no, not half $1, a little bit less when people buy this book. But this is a book written by different members of the community, including myself, but also Stephen Chin and many others. And that's from Apress, so you can learn from there as well. Well, there's an active JavaFX community. If you just on Twitter, if you will easily spot those guys, you can follow them. You can go to Stack Overflow, post questions tagged with JavaFX. And if you really want to go deeper in JavaFX, you can join the OpenJFX dev mailing lists. You can see all the source code of JavaFX in github.com/openjdk/jfx, and you can follow the development and contribute to the development there. So that is yeah, and then there are many people with their side projects. It's hard to name a few because I will definitely forget others. But if you just search for them, you can't miss them.
Right. Yeah, learning by example probably is the best. Personally, a book is not my preferred way to learn about things. But some people learn from books the best, and for those people, this is certainly a very good resource to have. Right. Thank you very much, Johan. I think I don't have any more questions. I think we've talked through most of my points that I want to get answers to today. Yeah, I will link every link that we had somewhere in the description of the videos when we upload them to things. And thank you very much, everyone who is watching. If you're doing this not right now live, then join and follow the accounts. We are going to do more sessions about GraalVM and Java and projects in the Java ecosystem. And yeah, any parting words?
I think it was. I'm very happy that you invited me here, and I truly believe that we are at the pivotal point in the IT industry, and I really think that the GraalVM is one of the biggest changes in the 25 plus years of Java, and the combination of GraalVM and Java still going strong, and JavaFX on the UI, and that with the 12 million Java developers and the ecosystem, that is really going to set the mark for the next 25 years. So this is not just new technology that I like and want to play with. This is really fantastic technology, and and I don't say that lightly. So I'm very happy that we can work together on this.
Thank you very much. I'm sure the team will appreciate that as well. The words of praise always find like a good listening ear in the open source maintainers. So if you're watching this and you're using some open source projects, go and say thanks to the maintainers. They never receive enough praise, and they mostly deal with the negative emotions there. Right. Yeah, and thank you for highlighting GraalVM's place in the ecosystem. Java ecosystem and community are huge, and there is a lot of work to do in order to even kind of not even convince, but even talk to everyone who is doing Java development. So yeah, every bit of positive feedback helps. And I'm sure that the combination JavaFX and GraalVM is a decent choice and option for all your development needs for the applications that need a UI. Right. Thank you very much, Johan, once again. If you're watching this, follow Johan on Twitter. He goes by @JohanVos. If you have questions that you didn't have a chance to ask live here, I'm sure he would be happy to chat with you online. And if you use JavaFX, look at the Gluon client Maven project build tools and all the helper functions that Gluon provides. Oh, my tongue is getting so twisted at the end here. Thank you very much. Anyway, we'll see you next week on another installment of the GraalVM streaming episode. And thanks, Johan, once again. Bye.
Thanks. Bye.